Have you ever really stopped to think about what's going on inside a dental filling or a crown? I mean, it's so much more than just a simple patch job. It's actually a piece of high-tech material science, engineered to survive in one of the most brutal environments you can possibly imagine, your own mouth.
So that really gets us to the core question, right? Why is the human mouth such a ridiculously tough place for any man-made material to exist? You'd think it's pretty common there, but oh man, you would be mistaken.
I mean, just think about it for a second. It's a world of constant, massive temperature shocks. It's soaking wet 24/7. It's got to look perfectly natural, which is a huge demand. And on top of all that, it gets crushed under incredible forces every single time you chew. So yeah, any material we put in there is literally in a constant fight for survival.
Okay, so let's tackle that first big challenge, temperature. Every single time you sip a hot coffee or dig into some ice cream, you're kicking off a thermal war inside your mouth. And your dental work, it's sitting right on the front lines.
So the first thing we got to talk about is something called thermal conductivity. All that really means is how fast does heat travel through something? Now, metals, like the kind used in some older fillings, are super conductive. That's fantastic if you're making a frying pan, but it is not what you want when that material is sitting millimeters away from the sensitive nerve in your tooth. And this is where the cleverness of dental science really comes into play. To solve that problem, dentists will often put a special insulating layer of cement underneath the metal filling. It's like a tiny thermal blanket for the nerve, shielding it from those sharp, painful shocks of hot and cold. It's such a simple idea, but it's incredibly effective. But, conductivity is only half the battle. There's another property that's maybe even more important. It's called the coefficient of thermal expansion. Look, in simple terms, everything gets a little bigger when it's hot and shrinks a little when it's cold. The really crucial part here is that the filling and the tooth have to expand and shrink together at almost the exact same rate. Now, this is where it gets really interesting. Just look at these numbers. A natural tooth expands at a rate of about 11.4. And look at porcelain, it's a beautiful match at 12.0. But then you look at amalgam or some composite resins, whoa. They expand and contract too, even 3 times more than the tooth does. So who cares, right? Why does that matter? Well, every time you drink something hot or cold, that mismatched material pulls away from the tooth on a microscopic level. It creates this tiny little gap around the edge, which we call marginal leakage. That gap breaks the seal and lets saliva and bacteria sneak in, which can cause sensitivity and, you guessed it, a brand new cavity right underneath the filling. Getting that match right is absolutely everything. All right, let's switch gears. Making a restoration that can survive is one thing, but making one that is totally, completely indistinguishable from a real tooth, well, that's a whole other level of science, where you have to blend physics with a healthy dose of artistry. To really get this, we need to think about color in 3 different ways. First, there's hue. That's just the basic color. And most teeth are kind of in the yellow to yellow-red family. Then you've got chroma, which is how intense or saturated that color is. But the most important one, the one that really makes a tooth look alive, is value. That's its lightness or darkness. And this quote just nails it perfectly. If you get the value wrong, the tooth just looks dead. A low-value crown looks gray and lifeless, but a high-value crown, it looks vibrant, it looks alive. It's literally the difference between a perfect match and a glaringly obvious fake. Now, for a really weird and cool phenomenon called metamorism, you know how you can buy a shirt that looks like the perfect color in the store, but when you get it outside, it looks totally different? That's metamorism. 2 things can look like a perfect color match under one kind of light, like in the dental office, but look like a total mismatch out in the sunshine. It's a huge, huge challenge in dentistry. So how in the world do they get around this? Well, they've got this really smart process. For the best result, they pick the shade at the very start of the appointment, before your teeth have a chance to dry out and change color. They'll even cover up any bright clothing you're wearing and ask you to remove lipstick to avoid color contamination. And ideally, they'll check the match under a couple of different light sources and even reset their eyes by looking at something neutral gray or blue. It's a pretty fascinating little process. Okay, so we've got a restoration that can survive the temperature swings and looks fantastic. But what about just living with it? How does it feel? How does it function every day? This is where a whole other set of physical properties comes into play. Let's start with density, which is really just a fancy way of saying how heavy something is for its size. And you might not think that's a big deal, but picture this, an upper denture. If that thing is too heavy, gravity is its mortal enemy, constantly trying to pull it down and make it loose. And this chart really tells the whole story. A denture made with a gold alloy is more than 8 times heavier than one made of acrylic resin. That is a massive difference. And it's exactly why modern dentures use these incredibly lightweight materials like acrylics. It makes a world of difference for comfort and for just keeping the darn thing in place. Okay, here's another one that's a bit more subtle, but still really important: water sorption. Basically, some materials, especially the acrylics we use for dentures, will actually soak up a tiny bit of water over time. It's not a lot, but this absorption can cause the material to change shape ever so slightly, which could affect how well a denture fits after many, many years. So, after all of this, after looking at temperature and aesthetics and weight and all these different challenges, you've got to be asking yourself, okay, so what's the one perfect, do-it-all dental material? And the answer is, there isn't one. The real secret to modern dental materials is that every single choice is a compromise. One material might be super strong but look a little off. Another might have a perfect thermal match but be too heavy for a denture. The real art of dentistry is picking the right material for the right job, carefully balancing all of these properties for what each patient actually needs. So let's just do a quick recap. What are the big things to remember? First, a filling has to expand and contract right in sync with your tooth to survive. Second, that natural look is all about mastering color, especially that all-important value. We also saw how something as simple as weight is the secret to a comfortable denture. And maybe the biggest takeaway of all is that choosing a material is always, always a scientific balancing act. Which really just leaves you with this incredible question to think about. We've come so far from simple metal patches. As our technology and materials science get better and better, what will the dental materials of the future be able to do? Will they be able to heal themselves, maybe even help regenerate the tooth? We can only imagine. Thanks for diving into this with me.